Let's execute this. And as usual, I'm importing a iris and dropping this. Okay, so okay, so there is something called a area. Okay, and also I wanted to tell everyone here that do not waste much of a time in the visualization. They look good, they design and all, and it gives a good feeling when you plot the graphs, right? Which is fine. But in a data science, right, we use a very minimum graphs to understand the data, right? We don't, go behind designing every graph, right? So you should know the types of graphs, but at the same time, we don't use all the graphs available, right? The code wise almost the same only. I'm sure most of you are already um, discussed. I mean, we already discussed that we just need to use this kind equal to, different names. All right, just an idea. I can use this df, the data frame dot plot, and kind equal to one more type is, or the kind is area, right? Area. So area is, it is going to show, okay, what is this color? Color is a sepal length. So this data fluctuates like this. This is how the data points are there, right? The very first data, sepal length 5.1, right? So this is the 5.1 point, right? This, let me take another color. So 5.1. Next one is 4.9. So 4.9. Then 4.7, somewhere 4.7 down maybe. Then 4.6. So basically it is trying to plot this all the numbers and it will connect everything. It will connect. So this is how that area looks like. The whole area of sepal length is like this. So what it will do, it will keep the lowest in the front, lowest data whatever we have, it is going to keep front. So accordingly, it will, so that we can visualize properly, right? So the red, the bars or the area what you see here, they are basically having a higher frequencies, right? Higher frequencies. So yeah, anyway, we don't use much of a area and all. It will not have much of a thing because we use something called a distributions and all, right? So the distributions and all will help to understand how the data is distributed and things like that. That will come very soon. All right. This is, we hardly use this area, especially in our course. We don't use any graph like area and all because we have some advanced things to understand, right? Fine, that is just to give an idea that yes, we have one more type. Now this is important, df dot plot. So we have used a scatter plot, right? Sorry, scatter matrix. We have used a scatter matrix. So in the scatter matrix, we have seen all the columns versus all the columns. Here I'm using only scatter, only scatter. So here I can use one column versus another column, only one versus one. And remember, whenever you use a scatter plot, you should have X data and Y data. It will not work with only one set of a data. So scatter plot is basically we use to compare or the relationship. Most of the time we use the scatter plot for finding the relationship of two variables. X is one variable, Y is one more variable. The relation between X and Y. Right? So yes, that's why we need both, or I would say two variables. So scatter X data and Y data. All right. So it will say sepal length is somewhere here, right? And which data from petal length is over here. So basically the relation looks like this. It is not making a much of sense. So for that, what I will do, I will explain one example here to understand this scatter plot. Let's say I have an experience, right? This is a X data. Let's say this is a salary. This is a Y data, X and Y, let's call it this way. So experience 2 years and salary say that 35K. Experience 2.5 years, maybe 38K. 5 years, 6 years, 6.5, so and so forth. Similarly, salary will be given to depending upon the experience. So this time, so here what we do, we try to understand the relation between experience and salary. If I plot a graph for this, so this is the experience, this is the salary. So if the experience is 2 years, let's say 1, 2, 3, 4, 5, 6, whatever it is number, let's say 10 years. This is 1 and this is 2. So 2 years is the experience and the salary, let's say start from here 10K, 20, 30, 40, 50 and up to 100. Right? So experience is 2 and his salary is 35K, right? So I will go straight here, move forward, and here is a 35, right? So this is the point. Similarly, 2.5, 38K. Suppose this is 2.5. I will extend this line, imaginary line, and go all the way here. This is, suppose this is 38. This is the 1 point. Similarly, as and when experience increases, salary will also increases. So our point will go something like this, right? So it will draw this line. So here we are not drawing a line, but if you see this data points, right? So this is basically coming out of a scatter plot. So here basically what I'm trying to do, trying to understand the relation between experience and salary. So when I can say there is a relationship. So if the data is going in this direction, this is a trend, right? So as and when experience increases, we know that salary is also given more and more, right? So this is the trend. So to identify this kind of a trend or the relationship, we use a scatter plot. Here we do not have the right amount of a data or the good, I would say, where we can establish a relation between X and Y. So this is how it is scattered. So this is how you can interpret X and Y. So we will discuss more about scatter plot. I think 90% of our, not 90, let's say 80% of our graphs are on a scatter plot, right? In our machine learning and all. You will keep seeing the scatter plot every now and then. All right? Fine. The same concept here, I have taken a different X and different Y. And I have chosen different color. Otherwise, same a technique only, df.plot.scatter. Right? Yeah, same thing, only thing is I'm changing X and Y, nothing else. Now, let's try to do something different here. So what we did, we have created this scatter plot for a sepal length, petal length. So basically it is related to length only. Right? So now also we created for sepal width and petal width. So this is related to width. So now my requirement is I wanted to combine both. So I wanted only one graph where I should plot length graph and width. Should be in the same graph. Will I be able to do it? Will I be able to join them? Yes. Let's look into that, how we can do it. So these are the same data, whatever I have written here, right? I will take the same one. I'm not going to change anything. Only thing we need to understand here, this is a sepal length, what we have seen. I will talk about a label, where it will print, how it will print and all, right? Just hold on. So scatter plot, X and Y. The whole thing I'm storing in one of the variable called AX. AX. You can give any name, doesn't matter. Usually AX is the axis. So one axis, any one axis. Fine, everything is stored. This is one of the graph only. Simple. Now what I'm going to do, I'm going to plot a scatter plot here. This time I'm going to use a width. Here I used a length, right? This time I'm going to use a width data, X and Y. Label, I will say width. Now I'm saying this is the important one. This is what makes both the graphs, get joined. AX, this is the axis, this is the parameter equal to this AX. You can give XYZ here, okay, no problem. You can give XYZ, right? So this AX, so the color I'm giving R. By default, color will be in the blue, right? So I have a plot. I have one plot already, which is in the AX. I am plotting one more scatter plot. In that, I am bringing the old one. That's how you can interpret. If I execute, now you can see that all are in the same plot. This label length, this is what the label. Width, label, yes. This is how you can give the name using a label parameter. Right? Red is denoted as width. All these are width related data. And this is a length related data. If you go back and check, they all same. They all same. You see this, right? So that's how you can interpret this.